Measuring length. For our warm-up, let's start by identifying angles, segments, rays, lines, and points in the figure shown on your screen. I'm going to start with angles, and the first angle that I've just traced over is angle GDE, or you could call it angle EDG as long as D is in the middle because D is the vertex. Use the angle symbol when you name it, angle GDE. Another angle that I see in this figure is the angle opening to the right, and that angle is angle EDF or FDE. Make sure D is in the middle because D is the vertex. We can also call it angle 2. That number there tells me that I can name it with the number that's in the middle there. It tells me specifically which angle I'm talking about. When I'm talking about angle 2, the reader also should know that that means angle EDF. Opening to the bottom, we have angle HDF. You could name it FDH instead. Make sure D is in the middle because D is the vertex. And opening to the left, we have angle GDH or angle HDG. If you saw the straight angle on here, that's fine. Angle GDF or angle FDG. And the other straight angle we have, angle HD and then E. Now, all these angles could be named in the exact reverse order, E, D, H, as long as D is in the middle because D is the vertex. Segments, you could start at D and go to E, calling it D, E. Put the segment bar over the top, no arrows because a segment has 2 endpoints. The exact same segment is also called segment ED. Order doesn't matter when you are naming segments. If you want a larger segment, we could start at H, go all the way over to E, or you could call it EH. You could take part of that segment, start at H, stop it at D, and that would be segment HD. On the line here, we could say that you have segment GD, you have segment DF, segment GF, and all of those could be written in reverse. Just make sure that you have the segment bar over the top of your 2 letters to show that it's a segment with 2 endpoints. Now, rays have 1 endpoint, and they go in one direction forever. When you name it, there's an arrow. It always goes towards the right. Doesn't matter what direction the ray itself is actually pointing in. You always start with the endpoint as your first letter and then show the second letter as the direction that it's going in. So in this case, I could call this HD or I could call it HE because I want the ray that starts at H and goes in the direction of both points D and E. You could have it start at D and go through E, so not including this part. Let's get rid of this part and say we want to have the ray start at D and go through E. Then that would be ray DE. We could have it start at D and go through G. That would be ray DG. Or we could have it start at F and go through G. That would be ray FG. If we wanted to have it start at G and go through F, it's a totally different ray. So that would be ray GF. With rays, order matters. The first point is your endpoint, and the second point that you name tells you which direction you want it to go in. If you're looking at a line and it goes in both directions forever, that ray is going to be have a stopping point, have an endpoint, say D, and then it's got to pick. Do you want it to go towards F? Do you want it to go towards G? So the 2 points, the order does matter. Endpoint first, the second point tells you which direction it goes in. Lines go in both directions forever. Doesn't matter which order you name the points in, you just need 2 points. There's 1 line in this drawing, and that line is the one I just traced over. You can name it GD, double arrow on the top, showing that it goes in both directions forever. You could name it DG, you could name it DF, or FD, or you could name it GF and FG. The other item on this drawing is not a line because it has an endpoint. Notice that it stops at H. So HD, although we would love to call it a line, it's not a line because it has this endpoint. It does not continue in both directions forever. Points on the figures are all those single letters. The points we have are point H, point G, point D, point E, and point F. The objectives for this lesson are to define length and congruent, identify and use the segment addition postulate, and construct a geometry ruler. Let's start by finding the length of a segment. When you find the length of a segment, it's like finding the distance between 2 points on a number line. In this case, I have point A and point B, and I can see that it's on a number line. I have 0. As I move towards the left, my numbers are going negative. As I move towards the right, my numbers are becoming positive. When we find the distance, we need to use the values, -3 and 4 in this case, because those are the values for point A and point B. And what we're going to do is find the absolute value of their difference. That means we're going to subtract and then find the absolute value of what we get when we subtract. In this case, I put the A first, -3 minus 4. That gives me the absolute value of -7. The absolute value of -7 is 7, because -7 is 7 units away from 0 on the number line. Let's say I reversed it. What if I put B first? If I put the point B first, I'm going to get 4 minus -3. Put my absolute value there because I want the absolute value of the differences. When I subtract a negative, I'm actually adding. I get the absolute value of 7, which is also 7. So order in this case doesn't matter. I could find the distance from A to B or the distance from B to A. All I need to do is find the absolute value of their differences. Our formulas, A minus B, B minus A, absolute value of both of them, and we just saw in the last example that in both cases we got 7, regardless of which point we put first. Let's go ahead and find the measures, or the lengths, of segment AB, segment AX, XB, all on the number line. I'm going to start by numbering my number line so I can see where the points A, X, and B are actually at. So I see that 0 is already numbered for me. I'm going to add a 1, and then I'm just going to count. It looks like B is at 4. And then as I go towards the left, I'm going to have negatives. I can see that A is at -4. The first point, or the first distance I want to find, is between A and B. So I'm going to find the absolute value of the difference between where point A is at and where point B is at. So to do that, I'm going to find where A is, -4 minus 4. -4 minus 4, that's -8. So I can see that the measure of AB is the absolute value of -8, which is 8. On my next one, to find the measure of AX, do the same thing we just did, only this time use the points for A and X. -4 minus 1. -4 minus 1 is -5. The absolute value of -5 is 5. So the measure of AX is 5. XB, I'm going to start with X and go to B. Now it wouldn't matter if I started at B and went to X. As we saw in the last example, I'm going to get the same answer. Let's check this one though and make sure. So if I start at X and go to B, I'm going to 1 minus 4, and that gives me -3. The absolute value of -3 is 3, and we're just going to check and make sure it works. If I start with B and go to X, that's saying 4 minus 1. 4 minus 1 is 3. Absolute value of 3? 3. So I got the same answer. It doesn't matter what order I put these in, as long as I'm taking the absolute value of the difference. The most common mistake people make is with that double negative. You want to make sure that you're careful with where you're putting your negatives and that you're subtracting the two numbers. Congruent figures are figures that are the same size and shape. Our symbol for congruence is right here. This says that XY, segment XY, is congruent to segment YZ. And to write that congruent symbol, what you're going to do is make an equal sign and then put a squiggle on top. If two segments have the same length as measured by a fair ruler, then the segments are congruent. Also, if two segments are congruent, then they have the same measure as measured by a fair ruler. So if you're asking yourself, what is a fair ruler? It's any ruler you usually use. Fair ruler just means that there's equal spacing between each of the numbers. So in this case, I made one, and each of these are 1 inch apart. So I've got a 1, a 2, a 3. They're all equally spaced. An unfair ruler would be one where you've got the numbers on it, and I'm saying from here to here is 1 unit, and then from here to here is 2 units, and then this little space is another unit. And so they're not equally spaced. When they're not equally spaced, it's not considered a fair ruler. So fair ruler just means a ruler where all of the spacing is equal. Let's use the segment congruence postulate to solve the following. If xy equals yz, then xy segment is congruent to yz. Now this equal tells me that I'm talking about the actual length of it, or the measure of it. It's 7 inches, 7 miles, 7 meters. Where this is just saying that the two items, or the two figures, are the same size. If the segment xy is congruent to segment yz, then xy equals yz. If a point R is between points P and Q on a number line, then PR plus RQ equals PQ. What this is saying is that if you've got R, you can find the distance from P to R and find the distance from R to Q and add those two numbers together to get the distance from P all the way to Q. Now you might use this on a map. When you're looking at a map, it'll give you the distance between two cities, but you actually want to go to another city, so you have to add the two distances together. How far will it get you? How far is it to go from one point to the next city, and then from that city to the city past that? Here's an example. The towns of Dyersburg, Newton, and St. Thomas are located along a straight portion of Ventura Highway. Newton is between St. Thomas and Dyersburg. The distance from Dyersburg to St. Thomas is 25 miles. The distance from Dyersburg to Newton is 1 mile more than 3 times the distance from Newton to St. Thomas. To solve this problem, let's draw a picture. Now, it doesn't necessarily have to be drawn to scale, so I'm just going to go ahead and say that's St. Thomas, and I know that Newton is somewhere in the middle. I don't know if it's directly centered. It doesn't have to be perfect. We're just going to kind of get a feel for where everything's at. So we have Newton in the middle, and then we have Dyersburg. And then one of our clues said that the distance from St. Thomas to Newton, compared to Newton to Dyersburg, Newton to Dyersburg is 1 more than 3 times the distance from St. Thomas to Newton. So I'm going to say St. Thomas to Newton is x. And if from Newton to Dyersburg it's 1 more than 3 times x, I can say that it is 3x plus 1. It also told us that the distance from St. Thomas all the way to Dyersburg is 25 miles. So now I'm going to set up an equation to solve. X plus 3x plus 1 equals 25. I've taken the distance from St. Thomas to Newton, which was x, and I added the distance from Newton to Dyersburg, which is 3x plus 1, and I set it equal to my total, which was 25. I'm going to combine like terms. This is 4x plus 1 equals 25. If we subtract 1 from both sides, we get 4x equals 24. So x equals 6. What that tells me, from St. Thomas to Newton is 6 miles. And from Newton to Dyersburg is 3 times 6 plus 1. That's 18 plus 1, or 19 miles. I can do a quick check. I know the total distance should be 25. If we take 6 plus 19, we get 25.